Hi guys, I hope you are all doing well. Let's see today's question. So today's question, we are taking this up from the topic of applications of integrals. And if I talk about the question that is given to us here from this topic, the question tells us to find the area of a region which is given by the curves. The first curve is y square less than or equals to 4x. The next one given is x less than 4. And the third one given to us here is x times y times x minus 1 times x minus 2 over x minus 3 times x minus 4. This entire expression is given to us greater than 0. And one more condition is given to us which says x is not equals to 3. So if I talk about the question here, the answer choices that are given to us for this question are 32 over 3, 16 over 3, 8 over 3, and 64 over 3. So we need to figure out which one of the answer choices is the correct answer for this area of the region that is asked to us here. Let's try to solve this question and understand further how to solve this question. So if I see here, I have been given the one line that I can easily plot, which is saying x is less than 4. So if I draw my two axes first, my x-axis and my y-axis. The x points are given to us 1, 2, 3, 4. They have told us x is less than 4. X is less than 4. Less than 4 basically means, I know x equals to 4 is this straight line which is parallel to y-axis, and x less than 4 means it is the region anywhere to the left. So it can be anywhere here. Now, one more region, if I see here, it's given to me y square is less than or equals to 4x. Now, if I plot y square is less than or equals to 4x, that is basically a parabola that we know already. And when it's a parabola and a straight line, if I draw both of them would intersect each other. We need to find the intersection points for both of them together. So if I intersect both of them, means I put x as 4 here, I get y square is 4 times 4, which is 16. The y square is, if 16, I get square root taken, y becomes plus or minus 4. If I put y as plus or minus 4, I understand for x equals to 4, y is either plus 4 or for x equals to 4 again, it's minus 4. So I have these 2 points with me. Now if I draw this curve y square equals to 4x, we know it's a parabola, so I'll draw a parabola here. So it looks like this. So this is how a parabola will look like. And because they have given us y square is less than or equals to 4x, less than or equals to means the value of y square would be less than or equals to 4x, means it will be inside this. So the common region to both of these curves is, it says this should be inside and this says it should be to the left of the line. So the common region to both of them would be this entire region. Now, one more condition is given to us, so we need to analyze that as well. So we'll understand what is the shaded region that we'll have, for which we have to find the area. One more thing that is given to us here is the product of all these terms divided by the product of these two terms is greater than or equals to 0. Now here, if you see, I have terms of x, but I have one y also. And y, if I see y according to the selected region, till now the region which we have, y can be both positive or negative. So I'll have two cases there. So case 1, where y would be greater than 0. If y is greater than 0, my expression given to me here was x, y, x minus 1, x minus 2 over x minus 3, x minus 4. This was greater than 0. So if y is positive, then the product of the remaining terms also should become positive. Now the product of all these terms if should become positive, because positive into positive will give me a positive answer. because y is positive, the product of all the other terms would also become positive, so that I get the total product also positive, because that's the condition given to us. Now I want to have this positive. To have this positive, I know the values of x that are permissible according to the shaded region go only from anywhere from x and till 4, not even equals to 4. So what I can do is I can just put x, if I put x as 0, it will become equal to 0. If I put x as 1, it will become equal to 0 again. If I put x as 2, it will again become equal to 0. So those are creating the issue. So what I can do is I can just use the idea to find my critical points. So my critical points are 0, 1, 2, 3, and 4. So I can put any one of the values between this regions that I have. So let's put 0.5. So if I put x as 0.5 here, I get 0.5. So this is positive. 0.5 minus 1, so negative. 0.5 minus 2, again a negative. 0.5 minus 4, again a negative value. And 0.5 minus 3 is also a negative value. So if you guys see, I have positive times negative, which is positive into positive. And here also negative into negative is also positive. So positive over positive I'm getting, and that's basically positive, which is greater than 0. So for the range of values of x anywhere, if I put from between 0 and 1, I'm going to get this entire expression positive here. So this entirely is positive. So I know then alternately I'll have negatives and positives. So 1 to 2 would be again negative. 2 to 3 will again become positive, and 3 to 4 will again become negative. Now, if you want to verify, let's verify it here. So let's take between 2 and 3 also one value, let's say 2.5. So if I take 2.5, this is definitely positive. 2.5 minus 1 also would be positive. 2.5 minus 2 would also be positive. So your numerator is still positive. Denominator, if you see 2.5 is less than 3, so that's definitely negative, and 2.5 minus 4 is also negative. So negative into negative will also make it positive. So that's greater than 0. So that condition is satisfied for the values of x between 2 and 3 as well. But for 1 and 2 and 3 and 4, it will always become negative for this expression. So those values of x will not satisfy. So the solution range that I get for this condition to be true is the values of x would be 0 to 1 anywhere and 2 to 3. So if I draw the lines, so y is greater than 0, I have found out case, and it is satisfying for this values of x between 0 and 1 and between 2 and 3. Now let's try to figure out if I put case 2 where y also can be negative. In that cases, what values of x gets satisfied. So if I'm putting y as negative now, if I put this as negative, the product of them still should become positive. So if this y alone is negative, then the product of all the remaining terms should also become negative, because negative times negative will give me a positive value. So from here, what I get is x times x minus 1 times x minus 2 divided by x minus 3 times x minus 4. The product of all the remaining terms also should become negative, because y is negative. So negative into negative will make it positive, which is our required case given to us. So let's try to evaluate for which values of x does this condition get satisfied now. Now again, I'll plot those points for x first. So x, if I see, goes from 0, 1, 2, 3, and 4. So if I put any value for x from between 0 and 1, let's again put 0.5 and verify. So 0.5 I put, this is still positive. We already figured out this when we put x as 0.5, the whole expression was turning positive here. We have seen that because it's the same case, right? So this whole thing becomes positive. So the alternate one becomes negative. The next one will again become positive, and the next one will again become negative. So I understand that for this values of x from 1 to 2 and from 3 to 4, I'll have this product negative. So I understand that x belongs from 1 to 2 and 3 to 4. So any value between 1 and 2 and any value between 3 and 4 gives me this entire product to become negative, and that basically makes the total condition given to us as positive. If you want to verify one more value, let's take some value and see if it's becoming negative. So let's take between 1 and 2. So I'll show it to you by the black ink, which is 1.5. So if I take 1.5, this is positive. 1.5 minus 1 is also positive. This was positive. This is positive. Now 1.5 minus 2 will become negative. 1.5 minus 3 also negative, 1.5 minus 4 also negative. So negative into negative, positive is my denominator. Numerator, if you guys see positive times positive, positive, and positive times negative, negative. So I get from here negative over positive, which is definitely negative. So I get this condition verified. Similarly, if you take between 3 and 4 also any value, let's take 3.5. So all the values 3.5 is greater than all this 3, but it's lesser than 4. So only this one will become negative, all others will be positive. So it will become positive over negative, which will still give me negative. So these values of x satisfy for this case where y is negative. So I get from 1 to 2 and from 3 to 4, y becomes negative. So let's draw the region there. So if I show you the region there, between 1 and 2 becomes negative, and between 3 and 4 also it becomes negative. So this is how my shaded region looks like, for which we have been asked to find the area now. Now, if you guys see, I can do, basically, if you see this part of the region, which is there, it's equivalent to this symmetric part above. So I can just shift this lower part up only here, and this lower part also I'll shift it up. So basically, if you see indirectly, I am trying to find the area between this part of the parabola, the positive part, and between my x-axis for the limits from 0 to 4. So I am basically trying to find out the area between this x-axis and between this parabola, which is y square equals 4x, from a vertical strip which goes for the values of x between 0 to 4. So I understand now if I want to find the area, I can just take the limits of x which goes from 0 to 4 and write y as a function. So y is basically y square was given 4x. So y in that case will become 2 root x. So instead of y, I can write it just 2 root x minus x-axis, which is basically 0. So from here I get 2, 0 to 4, root x dx. So that leaves me with 2. X raised to half will become x raised to 3 over 2 over 3 over 2 from 0 to 4. So I get 4 over 3. 4 raised to 3 over 2 minus 0 raised to 3 over 2. So I get 4 over 3. 4 raised to 3 over 2 means square root of 4, which is 2. 2 cubed is 8. That leaves me with 32 over 3. 32 over 3 square units is my area for the question that is asked to us here. I hope you have understood how to solve this type of questions. So A becomes the correct answer for this question here. So what we did was we first draw the line, we draw the graph of the parabola, we got the shaded region entirely. Then we tried for that third condition which was given. That gave me the shaded region was, which is shown in green, the upper region, the lower region, the upper region, and the lower region again. Then I just use the idea of symmetry because this lower region is exactly equal to this upper region. So I just shifted this here and this also here. So I easily understand that I have to basically find the area between this parabola and between the line. And once I found the area between the parabola and the x-axis, that is the line, I got the answer 32 over 3, which basically matches with answer choice A. So A becomes the correct answer for this question that was given to us here. I hope you have understood this very well. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, Please do like the videos as well and do subscribe to my channel and share this channel with your friends also who are involved in the preparation of questions on JEE so they can also take the benefit from these questions that we are solving. Thank you.